All right, we're back for day 24, part 2. We just calculated line of best fit, and we just did a calculation here. We should have uh, the sales would be 1250. And then we've got another question. If the band had 5,000 shirts to sell, what price could the vendor charge? So that's the Y value, isn't it? So here's my equation. And yours might be a little bit different, remember, just depending on what points you pick. And I can figure out, because the sales were 5,000, what X should be. I subtract 43.75 from each side. Grab the calculator and pound away. 43.75, and I get 625. And then something very strange happens here, because I want to divide by this number to get X alone. I divide by a negative. My answer is negative 625 divided by negative 875.5, or negative 187.5 is a negative 3.33, which doesn't make much sense. They should charge negative $3.33. Well, you could think of, instead of somebody paying money for a T-shirt, is that the company's paying them to take them away, right? So they should be paid $3.33 to take the T-shirt, which doesn't really make sense, right? So there's times when using the line of best fit to make a prediction doesn't make sense. And we can see that on our graph, that if we went back to 5,000 T-shirts, it would be a negative price, which just doesn't make sense. A few little points to end our lesson here. A line of best fit can also be called a trend line or a regression line. A fancier sort of university name for it, I might let that slip, or it might be in a textbook that you see, is least squares line. And that these all mean the same thing. Trend line, line of best fit, regression line. We'll see what regression is. That's a fancy math word too. We'll see what that means later. When we use a line of best fit to make predictions, it's called interpolation. Interpolation. When the prediction is among the known points. It's called extrapolation when the prediction is beyond the known points. So in the last question, the T-shirt question, we had two predictions, right? Predict and predict. One of them was among the points. D, because it was among the points that was given, D was interpolation. So this one was interpolation. For E, this one that was beyond the given points was extrapolation. This one was extrapolation. And it didn't make sense. But not always will that be the case, right? A lot of times extrapolation, for instance, we want to look about what the trend might be a few years into the future, right? And extrapolation would completely make sense. Outliers affect the position of a line of best fit. Remember, we discussed about whether the cases when we would include an outlier or not. Which line? This is from your textbook, and you don't have it on your sheet, but it is. Trust me. Which line of best? Which is the line of best fit? Justify your choice. This one looks good if you exclude the outliers, right? If you excluded the outliers and just said, no, these were measurement errors, we're going to, discount them, then these points only would be counted, and then this would be okay. But if those ones should be included, then this is no good because it doesn't count the outliers at all. This one, it sort of overcompensates for the two outliers and goes halfway between. So this one's no good either. This one's no good either because it overcompensates. Graph C here, you know, the two outliers pulled the line of best fit down a little bit, and that's okay. And notice if I had my loop here, a tight loop around all the points, does this go through exactly half? I'd probably rather see the line of best fit more like this, so it cuts my loop in closer to in half, but this is the best line of best fit. All right, have fun with your homework. That's it.